So with this one here, 5x squared plus 19x minus 4, the problem we've got with this one is, like the last one, it's different to the previous questions because the number of x squared, or y squared in this case, let's go for one like here. These are all like 1x squared, 1x squared. So we say that a is equal to 1. And in other words, why do I say that? Well, all quadratic equations will have a number of x squared plus a number of x's plus some number. Now, some of these numbers could be 0, but with an easier sort of introductory quadratic, this number will be 1, and so you just end up with just writing x squared. So, but in general, we can label these numbers with the symbols a, b, and c. So with this question here, a is 5, b is 19, and c is actually negative 4. So the harder questions are when a is not 1, okay? There are some ways of taking shortcuts occasionally, but I think I did that in another video. So, but for this one, there's no shortcuts available to us. So what we do is we first of all write out the brackets like that and leave them empty. And you want to think, well, we're going to be writing something here and something here, and that's going to be added to something here and something here. Now, the one on the left of the first one and on the left of the second one, they would, when you multiply this back out, so this is the factorized, well, it's not yet, but it will be the factorized version of the thing that they've given us. If I went backwards, I'd expand out my thing to get to what they've written. So in other words, this bit here multiplied this bit would have to be equal to 5x squared, and this bit multiplied that bit would have to be equal to negative 4. I'll explain that in a bit more clearly later on. But first of all, let's say that the left of each one would have to give us 5x squared. So the only solution we can have is 5x multiplied by x. Anything else wouldn't give us 5, as long as we use whole numbers, and we're going to use whole numbers. So we can say that, but we're not sure what we can say about the other two. Now, I said that when we multiply them out, it would give us to minus 4. But let's see that a bit more clearly, and also see how to find out the some of the other numbers. So what we're going to say about these mystery numbers here is we're going to call them m and n. Okay. So then we're just going to, now we've given them some mystery numbers, we're just going to expand it out. So let's start expanding it out. So we know that we want to make this, let's use a different color here, green. So first thing I'm going to do is I'm going to multiply that term by that term. That gives my first term once I've expanded it. And then I'm going to multiply that term by that term. That'll give me my second term. Then I'm going to multiply this by this. That'll give me my third term. And then multiply this by this. And that'll give me my fourth term. So let's do that. So the first term, 5x times x, is 5x squared. That looks good so far. That's what we've got up there. The second term, 5x times n, I'm going to write the n first. N times, okay, let's write 5n times x, okay? And the third term is m times x. And the fourth term is m times n. So what I'm going to do also is the middle two terms, this is what, whenever you expand a quadratic, the middle two terms can always be collected. In this case, it looks a bit more awkward because I've involved these m and n's, but we can still do it. So the first term we're going to be collecting x squared, x's, and I missed the plus sign, and leave this on its own. So we've got 5x squared plus, and what we can say here is we can say 5n plus m, all in brackets, multiplied by x. So I've kind of then factorized this bit in the middle. What I'm doing here is a very long-winded way of showing how to solve these questions here. And there's going to be shortcuts once we get the hang of it. But to start off with, we're just going to see it clearly. And then we've got plus m times n, and yeah, it's equal to 0. Now we can see that by comparing our thing down here with what we've got up there, we can see that this is obviously that. So that's fine. Now we can see why I was coming up with 5x times x, because it has to produce 5x squared eventually. Then the middle expression, all of this bit here, would have to equal to that. And then the final expression, m times n, would have to equal to not to 4, but to actually negative 4, because when you take away 4, that's the same as adding negative 4. So that means that I can say that m times n is equal to negative 4. And I can also say that 5n plus m must be equal to 19. 5n plus m is equal to 19. Now, the only way I can get a negative number by multiplying two numbers is if one of them is negative. So we've got a few combinations, really. Annoyingly, sometimes it's harder when you've got more combinations. Unfortunately, I'm just going to move this a little bit to give us a bit more space. Maybe if I zoom in a bit as well. So yeah, it's harder because we've got more combinations to work through. So what we do first is we look at the top bit. So our first equation, and then we look at the second equation afterwards. This is usually easier. Yeah. So what I do, if there's a few different combinations, is maybe do a table. So we've got m and n. Well, we could have m could be 1 and n could be negative 4, or m could be negative 4 and n could be 1. We could also have m is equal to 2 and n is equal to negative 2, or we could have m is equal to negative 2 and n is equal to 2. I think that are they all the combinations? Let's just think about this for a moment. No, that's not quite all the combinations actually, because we could have m is equal to negative 1 and n is equal to 4, or m is equal to 4 and n is equal to negative 1. Now they're all the combinations. So it's got quite a few different combinations, 6 different combinations. However, only one of them will satisfy equation 2. So we can work through these reasonably quickly without having to work it all out. We know that it has to add up to 19. So, and we know that when we multiply 4 by 5, we get 20, and we minus 1, we're going to get 19. So that's kind of a clue about we've got. So we're probably looking at 4s and 1s, aren't we, really? So if we multiply 4 by 5, we get 20. So I think n is going to be the 4 or negative 4, it seems. In fact, I think it's going to be 4, because if you have, I need to think this out, but 5 times 4, yeah. So 5n times n would be 5 times, oh no, the other way around, sorry. We want n to be 4, don't we? So it's this one. Second from the bottom. So 5n So it would be 5 times 4, which is, so let's just write 5 times 4 to start off with. Then plus m, which would be plus -1, so minus 1. That would be 20 take away 1, which is 19. So it's this combination here in this case. So back to this equation over here. I'll just zoom out a tiny bit. So this thing that we've got here was 5x. I've written the x and the 5 a bit too far apart, really. Plus m, which we now know is -1. So let's just do -1. And make sure that looks like a bracket. And then x plus n, and n is 4. And that's equal to 0. So if that's the case, then either the first bracket or the second bracket is equal to 0. So either 5x minus 1 is equal to 0, or x plus 4 is equal to 0. Rearranging that, let's do this bit a little bit quicker. 5x is equal to 1, divide both sides by 5, so x is equal to 1/5, or x is equal to -4. And hopefully when we put those back into the formula, we should get that answer. So yeah, when we run that through the equation, you do in both situations, whether x is 1/5 or x is 4, in both cases you get the whole lot equal to 0. So we've solved the equation. Okay, now once you've got the hang of this, it gets faster, of course. I've gone through it really slowly, but I recommend going through it really slowly at the beginning, because and then start to look for shortcuts after that. If you look for shortcuts too early, then you're going to get stuck on that autopilot thing that I mentioned earlier on, and that means that you're just going to go through the motions but not fully understand how you've got to each step, or realize what it is that you're doing. You might lose track of what it is that you're trying to do. But once once you've done that and you've done a bit more practice, you can start to take shortcuts, and you'll realize that, we're just looking for, we know that that's going to be 5x and x. We know that the m and n is going to multiply to give -4, and then we sort of, basically we start to jump stages. So we can jump to this one here, and then we can maybe do some of this bit in our heads. And like I said, I didn't bother going through each individual one. I was able to see we want it to equal to 19. So I'm thinking like 20 take away 1 would give 19. 20 would be 5 times 4. And so that's how I got to this bit here. So you can kind of get faster at it, but essentially you're doing the same stages. But definitely it's worthwhile doing it slowly at the beginning. Okay.